Okay, good morning, everyone. So thank you, Ikeguchi-sensei, for introduction. So let's start the first session of the FugakuNEXT. And this session is dedicated for the HPC applications, and I will talk about the development and co-design for the FugakuNEXT. Okay, I am from RIKEN Center for Computational Science, team principal of the field theory research team and next generation HPC application development unit leader. Okay, so this table shows the expected specification of the FugakuNEXT machine compared to the Fugaku current machine. And for example, the by FP64 vector operation is expected to like more than 5 times improvements from the Fugaku. And the important specification is this one. The matrix operation like FP16, BF16 is much improved compared to the FP64. And this is this will be made available due to the tensor cores, which is embedded in the GPU in the FugakuNEXT machine. Due to that, we, the scientists, need to make use of these machines, if it is possible, in your applications. And of course, this is meant to be good apparatus for the AI applications. And scientists also need to consider the AI applications built into your applications to utilize the FugakuNEXT machine. So this is the machine figure. Consists of the component of the node and various components within node, of course, the CPU and the GPUs, which is connected with scale-out network. And for the GPU, the scale-up network is used. Also, as there are CPU and GPU heterogeneous environment, there are certain hierarchies of the memory on CPU and GPU, and also the hierarchy in the networks. So this is the point that is complicated point, the feature, compared to the Fugaku, which is, compared to this one, very simple. So we need to utilize this hierarchy in the applications. That is our goal towards the year 2030, when the FugakuNEXT is expected to start operation. So this table compared to the specification and application evaluation performance compared to the our first machine, K computer, to Fugaku current machine and to the FugakuNEXT machine. As I said that the FP64 performance is improved, but not like from the K computer to Fugaku, which was approximately 40 times, and this time is like about 6 times. So we need to make every effort to further speed up the applications, like use of the tensor cores in the computation directory, and also using the AI. So this is a timeline of the FugakuNEXT research and development, starting from fiscal year 2022, 3 or 4 years ago already. And the feasibility study was started in middle of the year 2022. And now we are in this phase, basic design phase. And in the next fiscal year from April this year, the detailed design phase will be started, and eventually it will be connected to the full operation of the FugakuNEXT in year 2030. there was a feasibility study project, and this is the organization chart of the feasibility study until the end of last fiscal year. And we have a company corporation, and we have a bunch of teams, system architecture and the system software, and also the application and benchmarking. So we want to utilize this structure, which was working very well until the year 2024, and made a new but similar structure for the FugakuNEXT development. So this is the one-page slide showing the structure of the application area in the FugakuNEXT project, which consists of the two working groups. One is the HPC Application Working Group, and the other is the Benchmark Working Group. So as highlighted here, the structure is inherited from the feasibility study mostly. And the Benchmark Working Group, that was the sub-group in the feasibility study, is now elevated to the full working group, like this one. So this is a kind of busy page, and the application working group mainly works on the application development and also the core design using these applications. And there are life science sub-working groups, new material, weather, climate, earthquake, tsunami, and manufacturing, fundamental science, and smart city, and the numerical computing technology, machine learning algorithms. So there are 8 working groups. For example, related with this session, I myself is from the fundamental science field. And this sub-working group is now consists of the one organizer and one liaison. Organizer is mostly in all the sub-working groups named the R-CCS original researchers are named for the organizer. And they are organizing the sub-working groups. And the important person is the liaison, which is from the community of the application, each area. And the new material energy, like this, Dr. Dawson from R-CCS is the organizer, Dr. Yamaji Nims is the liaison. Manufacturing, Dr. Onishi R-CCS is the organizer, Professor Takaki JAXA is the liaison. And the next speaker, Professor Chisachi Kato, is one of the members of the manufacturing sub-working group and acts as an advisor in that group as well. So this is showing the relation within this FugakuNEXT project. So I spoke about the HPC Application Working Group and the Benchmark Working Group, which is in the application development area. And there are 4 different areas, 3 other areas, architecture area, system software area, and operation technology area. Those areas working together to make the FugakuNEXT project successful. And we, application area, 2 working groups, are working closely with the architecture area through the core design working group in the architecture area side, and also the micronode architecture working group and the system network working group there. And of course, we are working with the vendors, Fujitsu company and the NVIDIA company for the core design and application development as well. Eventually, we will, application area will be collaborating with the system software area, and also some part is already started. And eventually, towards the 2030 operation technology area, the collaboration with the operation technology area will be needed. So the basic design phase, we are currently here. So this is the magnification of this basic design area term, starting from the January 2025, and now we are in the January 2026. The vendor, CPU vendor is determined, and also the GPU vendor is determined, and we are working together to make this project successful. Okay, So the application development area, these are some itemized themes that we are working on. One is the application development and the development support. We need to have first select applications from HPC community. And we need to do the GPU porting, restructuring, like making use of CPU memory, etc., and tuning on the GPU machine and also for the GPU. We may need to consider also the use of low precision arithmetic to utilize the tensor cores. One example, good example, is the Osaka scheme. And the development of the use of the case of the AI in application algorithm is also important. There may be the other advanced technologies that we need to utilize. And these application developments, we eventually may need to do some automatic porting and tuning, and which is not currently operated, but we are trying to prepare for such development procedure. So the benchmark is, of course, important, and we need to do the benchmark on the current machines. And there we need to understand the requirement for the computing and leading to performance estimate of the FugakuNEXT. So co-design, extracting information from applications for co-design. And I will talk about what the EEA means in the next slide, but using this EEA for the co-design is ongoing. So the relation with application community for the ecosystem creation is, of course, very important. So the community for the current leading HPC applications, the AI use case for the HPC need to be studied, and we need to acquire much information and utilize AI use in the next development. So we may need to expand the reach of the potential users, not only the users of the current supercomputing facilities like Fugaku, but maybe there are needs for the other applications which may run efficiently on the FugakuNEXT, because the architecture and the philosophy is completely different from the Fugaku. So this is EEA, early evaluation application, what we call, and we call suggestion from the sub-working groups. If you remember, there are 8 sub-working groups, and we asked each sub-working groups to nominate 1 or 2 applications in each sub-working groups. And this is the table of the applications that each sub-working group named. So there are like 14 or 16 applications now, and this fiscal year, especially, we started with the detailed analysis and the tuning of the application for the co-design in the following years. And for that purpose, we selected 6 applications out of these 15 or 16, 14 applications. So they will be they are now under the program analysis, performance estimate, and tuning using the current GPU. And this project and work is done using the help of the NVIDIA company and also the Fujitsu company. This is the sketch or kind of busy table, which is showing how our continuous development and the continuous sort of CI/CD and CB, continuous benchmark, is packaged in the idea. This slide is actually made by the Sato Kent-san in the system software area leader, and which is involved for how the application is developed in this framework, and also how the system software is developed in this framework. And this is very much involved. So next page, the simplified version concentrating on the application development is shown. So there are application community, and we are in application development area, which we collected already, the EEA applications, and the list will be expanded in the future years. And that application is put into this framework. First of all, we need to do the application development history collection. We need to keep the history in our repository. And application evaluation is also important. And we need to do the application benchmarks in this process using the currently available machines like Fugaku and GPU machines. There are certain machines in the R-CCS that we call the R-CCS cloud machines, and that will be expanded and used in the future R&D for this project. Okay, and this section is not really prepared and open for now, but we plan to do this kind of systematic system, source code repository and the benchmark results is automatically taken, and automatically visualization is made. And this output is, of course, is a very important output for the system parameter determination in the architecture area in the future, in the coming years. And of course, this result of the evaluation is feedback to the application community for further tuning and for the application. So the CX systems of FugakuNEXT application development. So we have the benchmark, which is kind of famous in this community, which is made by the DOE lab, mainly Lawrence Livermore. And we had a hackathon in R-CCS last week, actually, for the EEA developers, so that we can put EEA applications onto this nice benchmark system. This event was co-organized by the Lawrence Livermore National Laboratory. And we have also the lightweight bench kit. We named the bench kit, which is also used to do the benchmark and also organizing this CI/CD/CD system. Okay, and the performance evaluation system for FugakuNEXT is being prepared and to be made open for potential FugakuNEXT developers. This is not really like this involved stuff, but now the current stage is simple and not really fully automated. But we will make this system open for potential developers in the near future. Currently, application which is to be run on the FugakuNEXT needs to be put either in benchmark or the bench kit. Okay, so I think my time is running out. But I will quickly go through these relations. Of course, the relation with the computational science community is important, mostly domestic. This is done through sub-working groups. And also, we have a hearing session with the leading researchers in the community. High-performance computer science community relation, of course, is important. And this is done through the other areas like application, the system software and also system architecture area in this project. And there is this hair desk, I'm sorry, the spelling miss here, there is E here, led by Professor Taisuke Boku, and there is one center hair desk is established in the list in this in a few months ago. And we are collaborating then on the application development. HPC community international, of course, is important. Relation with the HPC community is important, especially DOE labs. And other international relations like ceremony here today, maybe a future international potential collaboration will be we foreseen. So, altogether, these relations feel that more important and effective for FugakuNEXT system than the previous system, because the FugakuNEXT system in the year 2030 will be the cutting-edge, world-leading machine, not only for the Japanese domestic, but also the worldwide sense. Okay, to summarize, FugakuNEXT application development and co-design is underway. This year in the basic design phase, early evaluation application is nominated, and some applications are under tuning performance evaluation. Survey, I didn't talk about that, but we did a survey to have answer from the application developers through the sub-working group, like how much memory you would expect, how much network bandwidth you would expect, something like that. Such kind of survey was done. And also we utilize the statistical data, the Fugaku operation, especially recent year, last fiscal year data is very much useful to do the co-design. And CX framework, I talked about that. Automatic deployment and benchmarking is planned using these CX frameworks. And we are doing the benchmark using the Fugaku and the current GPU machines. Use case classification is important task. And this is just started, and this is more important in the coming years. Details described in this basic design report is completed in March 2026. And the contents with critical information removed is planned to be open in this page. And actually, if you look at this page, currently not really many informations are there, but there are a list of the FugakuNEXT application seminar, and the seminar materials are already available. So please check that. It's very interesting seminars. So, sorry, time is running out, but I want to announce that workshop at Tokyo and online. Unfortunately, this is Japanese for the foreign participants. So this is aiming for discussion with application developers. And the March 6th, we have this workshop, and the web page is open like this. Okay. So if there is any question to my talk,